Welcome to Unit 3. This unit is about energy, work, and power. And 3.1 is about kinetic and potential energy. Here's a video. We have two cars. There's the red car right here. There's the blue car right here. Which car do we think has more energy? Well, which car is faster? We know that blue car is moving faster once they start moving. So we can say blue car has more energy because blue car moves faster. So what's the idea? Faster is more energy. In other words, things are moving fast, have more energy. We can say that the blue car has kinetic energy. Kinetic means moving. So kinetic energy is energy from motion. Motion means moving. How do we calculate kinetic energy? Kinetic energy is 1/2 mv squared, where m is mass, v is velocity. So for example, a constant speed car has a mass of 4 kilograms. Speed is 3, so for the magnitude, the number for the velocity is 3. We want to find kinetic energy. Kinetic energy is 1/2 mv squared. We can plug this in. That's 1/2 times 4 kilograms times 3 meters per second squared. That's the same thing as 1 divided by 2 times 4 times 3 meters per second times 3 meters per second. We can put this in Google. 1 divided by 2 times 4 times 3 times 3. We get 18. So this is 18. What are units? Well, we have kilograms. We have 2 meters on top, meters squared. We have 2 seconds on the bottom, so per second squared. But another way of writing that is just 18 joules, because kilogram meter squared per second squared is just a joule. So we can write it, J is a joule. Okay? J is a joule. Okay. Next one. So we have 2 skateboarders. We know that when the skateboarder goes up, the skateboarder will come down, go back up, down, up, down, up, like that. Which skateboarder, A or B, will have more energy when they come down? It's gotta be A, because A starts out higher. Higher means greater height. A starts out higher. So what we can say is that person A has more potential energy. Okay. Another example. Which skier will have more energy when they come down? Well, we know that the blue skier will have more energy, because the blue skier starts out at a higher height. So we can say that what we like to say is that up here, so on the bottom, we know that the blue skier will be faster, so more kinetic energy. The way we describe it is that on top, the energy is a different type, is kinetic, is potential. So the blue skier is higher, so more potential energy. Potential energy is stored energy, and gravitational potential energy is stored energy from height. Anytime we have something and if it can fall, if there can be a change in height, we say that it has some sort of potential energy that's stored. We say that potential energy, more accurately, the change in potential energy, this is called delta. The symbol is called delta. The change in potential energy is mass times gravity times the change in height. Okay. Again, this is acceleration due to gravity, which is about 10 on Earth. Okay. For example, a 4-kilogram book is at a height of 1.5 meters. That's relative to the ground, so that means delta H is 1.5, because the idea is that if the book falls, it will fall 1.5 meters. We found the change in potential energy relative to the ground. So if the book falls to the ground, how much will potential energy change? Delta means change. This is really one thing, delta H. So that's going to equal 4. Gravity is 10. That's just 5. That's 4 times 10 times 1.5, which is about 60. So the change in potential energy would be 60 joules if it falls to the ground. A 1.5 kilograms binder is lifted from a height of 1 meter to a height of 3 meters. That means that the change in height will be 3 meters minus 1 meter, which is 2 meters. Mass is 1.5 kilograms. We want the change in potential energy. So same idea. Mass is 1.5. Gravity is 10 on Earth. Change in height is 2. When we multiply these together, we'll get 30 joules. Okay. If the kinetic is 20 and the potential is 30, the total energy would be 50 joules. There's a name for this. It's called mechanical energy. Okay. So going back to the skateboarder, on top, we see that the energy is basically all potential. On the bottom, kinetic, potential, some of each, almost all kinetic, potential, kinetic, potential, kinetic, potential. Okay. So here is almost all potential energy. B, it's some potential, some kinetic. C, when it's on the bottom, is basically all kinetic. D, it's some of each, potential, some kinetic. And when we get to the top, it's back to potential. If we calculate, we might get this. What is the mechanical energy? Well, we add 0 plus 4,200. That's 4,200. When you add them up, this is what you'll get. What do we notice? The mechanical energy is the same for all of them. The idea is that if there is no friction, total mechanical energy stays the same. This is called conservation of energy. Conservation energy means it stays the same. Okay? That's it.